administrator, martial artist, and critically acclaimed author. He was on the internet before the web existed and now works for an independent telecommunications wholesaler in Michigan. His recent books include Absolute BSD, second edition, DNS Sect Mastery, SSH Mastery, Network Flow Analysis, and the forthcoming Sudo Mastery.
I couldn't have done a better introduction if I'd written it myself.
In fact, you did.
Mug, November 2013.
So not only does he write books, he writes introductions. So I'm going to turn the stage over to Michael. So thank you very much.
Thank you, Jim. Hello, everybody. This worked 2 minutes ago.
You used your one chance.
Yeah, but nobody was looking then.
Oh, there you go.
Okay.
That's pretty quick.
So, hi, my name is Michael Lucas. And he just covered this whole slide, so we're going to skip it. So, this talk is on Open BSD. Let me start off with giving credit where it's due. The Open BSD folks put all of their papers that they have ever done at any conference up on their website, which I stole liberally from. And some of the more recent stuff came from Theodoret's keynote a couple months ago. I've written this presentation from scratch, and I'm not entirely sure how long it will take. So I've tried to arrange it so you can tell me to get off the stage at any time. This means you should feel free to ask questions whenever. And typos, there will be some. Why am I here? Jim, if you hate this presentation, please take it out on him. So, Open BSD. What is it and why should you care? It is yet another free Unix-like operating system. According to their website, their emphasis is portability, standardization, correctness, proactive security, and integrated cryptography. BSD, any of the BSDs really, is a complete operating system. It's not a distribution like you're more familiar with in Linux. A BSD operating system is everything. I'm looking around the room, some of you probably were using BSD when it was just plain BSD. BSD as a project goes back to 1979 and is based on original AT&T Unix. If anybody's interested in the history from 40 years ago, I can go into that. But okay, so OpenBSD. What do people know about them from the outside? From talking to people, this seems to be their reputation. They're cranky. They don't support all the hardware you would want. They focus entirely on security, and they're from Canada. And this is what people know.
See, the first one and the last one, they contradict each other. Canadians are generally some of the friendliest people in the world.
Generally, that's an important word.
Okay.
They are the exception that proves the rule. At least according to the reputation. So, that whole reputation comes from their way of doing things. Their license is a pure BSD license, or a modern BSD license. They are absolutely fanatical about doing things correctly or not doing them at all. Another thing that's a little different is that OpenBSD is written for the people who write it. And they put it up for other people to use. But they don't really proselytize. They don't try to get people to switch to the OpenBSD way. Linux users are frequently a lot more open and friendly and try to suck you in. They convince you that the first hit is free and that once it's on your hard drive, you'll never go back. And the Open BSD folks are more like, yeah, here it is, we use it, it works, it would solve your problem, but if you'd rather have your problem, that's okay with us. They're perfectly happy to sit back and see you struggle with whatever problem they've already solved. And the other thing is, Open BSD is something of a pressure point for improving the world. And they've done this several times, and I'll go through a couple of those. The big difference in licensing, the BSD license, the modern BSD license, yes, it's had a long history, but essentially today, the BSD style license comes down to three things. Leave our copyright notice on the code. We wrote this, don't claim you wrote it. It's fairly common sense for a lot of us, but some companies have had difficulty with this in the past. Leave the copyright notice in the code. If you ship the code compiled, put it in your documentation somewhere, and if you use this and it breaks, don't blame us. We are not claiming it is suitable for anything. But what this really boils down to, there are some distinct philosophical differences between BSD licensing and Linux licensing. The GPL, how many of you have read the GPL? I have read it, and I've tried to figure out how it is a software license. It's an interesting political document, but it's not a traditional software license saying what you can and cannot do with it. That's in there, it's buried in there, but a lot of lawyers make a lot of money trying to figure out what the GPL really is. But really, it's share and share alike, and that's a great thing. We try to teach our kids to share. There is absolutely nothing wrong with that. The BSD license code is more of a gift. As a BSD guy, we don't care what you do with the code. You taking BSD code and embedding it in a product and selling it to people doesn't hurt us, we don't care, and essentially, I look at it this way. A lot of people have very strong viewpoints on things like Microsoft took the BSD TCP/IP stack and put it in Windows, back in the Windows 95 days. Yeah, I see a couple blank looks. There was this thing called Windows 95 that didn't have network support. And there was a lot of discussion on, well, this was just awful, they just stole the code. But turn this around. Imagine the cost in human suffering if Microsoft had written their own. Now, we all had enough pain, thank you.
Well, they wouldn't have done that anyway, and everybody would have switched.
Yeah.
Address Kerberos, though. That's, 95 is one example. The other one is where they took Kerberos, perverted it.
That is a whole, okay, address Kerberos. Microsoft are cretins? No, okay, a little more
Let's go
detail.
without saying.
Kerberos is an open authentication standard that is also under the BSD license, and they took it, they embraced it, and they extended it so that you can use Active Directory as an authentication point for Unix systems. But you cannot use Unix systems as an authentication point for Active Directory.
Imagine that.
Yes, imagine that. That is what Microsoft does. And that played a key role in the antitrust trial, and that's one reason why we now have Samba 4 can act as a domain controller. And Microsoft paid to have that written. So they actually employ various Samba people to work on Samba and make sure that you can use a Unix host as a Kerberos source. So yes, if a company is going to be a cretin, a software license is not the way to solve that problem. So Open BSD was one of the first BSD projects to completely and truly audit their source tree and make sure that every single file was under this license. And this had some interesting implications. How many of you are familiar with VRP? Okay, Virtual Router Redundancy Protocol. Cisco and a bunch of companies sat down and said, you know, our routers are not as reliable as we'd like them to be. It would be really nice if you could have two routers, and if one of them died, the other router would say, oh, I better take over the default gateway IP. This is not a big revelation to anyone in this room, I'm sure. But they wrote a protocol for it. And the Cisco licensing says, you can implement VRP so long as you don't sue Cisco. From Cisco's point of view, this is very reasonable. Here's this protocol. Don't sue us if it breaks. If I ran a big company, I'd insist on something like that as well. The Open BSD code has 3 license terms. Keep our copyright on the source, keep our copyright on the binaries, and don't sue us. Cisco's extra licensing would have added a 4th term to the operating system. Therefore, that's unacceptable. Therefore, the OpenBSD guys would not include would not include VRP in the base operating system. But they wanted a virtual router redundancy protocol-like thing. So they went away and wrote the Common Address Redundancy Protocol, or CARP, and included that. Then they went to the IETF and said, we'd like a protocol number for our redundancy protocol. And the IETF told them, you can't have one because your protocol is too much like VRP. And you should just use VRP. So, there were some choices. They could have used a local-only number, but they chose to use the same protocol number that Cisco used for VRP, which is like saying port 80 is HTTP and it's my special protocol. The interesting thing was when you put 2 CARP hosts on a network with 2 VRP hosts, if, say, you have 2 firewalls next to your 2 routers so everything can fail over, the Cisco routers crashed and died because they saw VRP lacks some fairly basic things, at least back in the early 2000s when this was going on. VRP lacked things like authentication and checksumming. So when it saw these weird packets on the wire, the router just fell over. Cisco now programs VRP at least a little more defensively. But lots of finger pointing over this, lots of name calling. there are people on both sides who say this was great, this was awful. Yes, sir.
Were these implementing the same protocol or simply two different protocols with the same purpose?
Two similar but different protocols with the same purpose. The end result of all this, Cisco now supports CARP. Not on all their products, but scattered throughout, where a customer has demanded it, they support CARP. So, another big philosophical point, do it right or don't do it. The people in this room know better. It's not always the operating system's fault. Usually, when something goes wrong, there's an application that went haywire. Somebody did something they shouldn't do. But the truth is, no, it's the operating system's fault. You blame Linux, you blame Windows, you blame whatever. So, the Open BSD guys say, no, it is our fault. If you somehow crash the operating system, it's our fault. If your program goes amok, it should not take down the machine. But this has a couple of impacts on how they do things. Blobs, binary objects. Vendors provide device drivers as these binary objects for Microsoft operating systems. How many of you have a Linux desktop or laptop with some driver provided by the operating system vendor? Okay. This code is running in the kernel. The kernel doesn't have a huge amount of internal protection against other parts of the kernel. This means this driver really could do anything. It could corrupt the file system. It could send all of your keystrokes to the NSA. Anything. So the OpenBSD guys said, no binary-only drivers. We do not support them. There is a mechanism for loading dynamic objects into the kernel, but you have to go through a couple steps to enable it, and they're pretty much labeled shoot foot here. So, non-disclosure agreements are kind of similar. Someone gets an NDA, they write a driver, send it off in the tree. But who's supposed to check that driver? Who's supposed to make sure that driver actually works the way you think it does? I mean, how many of you have written code that you looked at later and said, I don't know why this works. It really shouldn't. Now, I'm a very weak programmer. I do shell and Perl. And I have looked at Perl scripts 6 months later and said, was I stoned? How did this ever achieve the result it gets? So, non-disclosure agreement means it's very hard to audit that code and check it for stupidity versus, no, this is really what the driver needs. Because the hardware vendors have the exact same problem. Sometimes they're not sure how their hardware works at all. So, the target users. This is probably the easiest thing to explain. It's written for themselves. They add features because they need them. They wrote the CARP redundancy protocol because a couple guys were using OpenBSD as firewalls and said, hey, we need failover. We're running on 386 hardware and this stuff is crap. They provide everything you need to actually use the operating system. There is full documentation on the actual system. If this doesn't work for you, there are lots of people who are really trying to suck you in as users. Everyone from Apple to FreeBSD to Linux wants you. They want you. They're just not really willing to do any effort to get you to switch. Because if they need to expend the effort, well, they'd rather be writing code. And if you want a new feature, here's the system source code. Send us a patch. So, you can use Open BSD for anything you like. You can even use it as a model for suing Cisco. Chances are that lawsuit is not going to work, but you can bury it in your product, whatever you want. We don't care. Many people have taken Open BSD or some other BSD system and used it to create an embedded device. And if you go looking around the world, people from EMC down to home router manufacturers are using some BSD, Open BSD, something, as the heart of their system. So, I have a room full of Linux fans. If you were to go get an Open BSD CD, plug it in and spin it up, what would you expect? And I messed up the slide order. Yes. Could I have is there some person who'd like to volunteer for a moment? Sir, come here. You're like in good health and everything. Yeah, no major injuries I should be aware of.
Not yet.
Okay. Do me a favor and hold up your hands. See, a pressure point is something, it's a term we use in martial arts, where you can, if you're holding someone the right way, you can make them move around and really do whatever you want. Basically steer them however you wish, or, okay? Yeah, okay. So, if this was the body of internet software, Open BSD is like that. Thank you, sir. Yes, Open BSD is a pressure point. So, what that really means is, computer research is pretty much dead. How many of you have seen Microsoft actually stop supporting an API? Say, no, we no longer let you do that. Your old software doesn't work. No, it does not happen.
Well, XP.
XP,
No.
no, XP as an operating system is no longer supported, but the APIs that you use to write code, my copy of Office 97 still runs on Windows 7.
Does DeskView run? Does DeskView?
Haven't tried. My gut answer is yes. So, there are all these good ideas for improving security, for improving operating systems as a whole. But as long as the old stuff still works the way it used to, nothing really changes. So, how does this tie back to pressure points? We've known for 20 years it would be a really good idea if memory was not allocated in strict stack order. If you were to shuffle things around, you would eliminate entire classes of not just security vulnerabilities, but problems. Buffer overflows would be much harder to do. The compiler support was there, but nobody really wanted to pick up on it because, once again, we don't know why our code works. And there is code out there that at one point depended on actually having internal buffer overflows so that, some other part of the process could pick that out. And there was code out there that was just written wrong but seemed to work. And if it crashed every now and then, well, file a bug report. So, the compilers knew how to randomize memory. But nobody wanted to turn it on because all of this third-party software just fell over and died. And it died horrible, unpredictable deaths. Even simple things like WRX, marking a piece of memory as either writable by a process or executable by a process. Programs are divided between the executable code and the memory of the stuff that it's actually trying to work on. And a program should never overwrite its own executable code in memory. At least not the majority of software. There are exceptions.
Okay.
Yeah, there are people who are doing really clever things, and
Exception.
yes, there's always an exception. So, Open BSD said, this is the right thing to do. We're going to break a whole bunch of third-party software. Went through their own tree, made sure everything worked with memory randomization, did a fresh release, and then turned it on globally. So they had, I believe it was 3.2, no memory randomization, 3.2 plus 1 day memory randomization. And they had a whole release cycle. So, what happened? If it had some kind of memory allocation bug, it broke. Open BSD has enough users. If you are the maintainer of a software project, I'm going to pick on Emacs here because I actually use it. And yeah, Emacs is a wonderful operating system. If you maintain something like Emacs and you get a bug report that says, I turned on memory randomization in my operating system and Emacs totally crapped out, you're going to go, you're an idiot. Don't turn this on. Everybody knows everything breaks. If you get 300 bug reports that say, Emacs no longer runs on Open BSD, here is my bug report, you'll take another look at it. And yes, it's the same root cause. The code was crap as far as buffer overflows and memory leaks and all of that. But the end result was it compelled people. Software authors were kind of picked up by this fragile little pressure point and dragged around until they fixed their code. And the result of this was, no matter what operating system you're running, you have a lot fewer of that class of problems. So, you're running Linux, you're running Emacs on Linux, you have many fewer bugs because of this. This dragged the world forward, whether it liked it or not. And as someone who was on the mailing list at the time, they liked it not. And then, once the Open BSD guys and their users filed all these bug reports and got everything fixed, over the next couple years, lots of other operating systems took the same plunge and turned on their memory address randomization. Most Linux kernels either ship with this now, or It's a sysctl you just turn on and off. So, what are some other things security related Open BSD has done? OpenSSH, how many of you use OpenSSH? I'm going to assume that people have not raised their hand.